So now we move on to talk about how to implement this in Python, right? We already went through the different distributions. Basically the uniform distribution, which you get from numpy.random.random, and then the normal distribution, which you get from numpy.random.randn. So previously we've been importing using this format, which you can also still do. We already imported we already imported numpy. So to use the random function, say I want one random number, I call it my rand. You could create it from the np, which is numpy package.random.random, like we did before, for uniformly distributed numbers. And then for normal distribution, you can access it this way. This works. You want 5 of them, right? But what we're doing here is showing you a different way. So instead of typing all of these out, if you want to be able to use random directly, like so, then you can use this form of import statement. So you say from numpy.random import just the random function for normal distribution. And subsequently, you will see we just do this directly. But whereas this one we imported using the long form of the function. So if you want to be able to do this, we can also use this kind of setup, and it will import just the Ctrl V to import just the random function. So we can try it. So with Python, always try stuff. Don't just take my word or take anybody's word for that matter. Just try it, and then you see here it works. And there is something I want to try myself. I believe you should be able to do this. And so you don't have to type it out multiple times. And then if it doesn't work, then you know, oh, maybe I forgot how to do it, but it works. So you're asking for 2 functions. Make these 2 functions available for me. Get them from the numpy.random package. So from numpy.random, import random and import random. And then you can use them directly. But keep in mind, they are not standard Python functionality, right? We imported them and made them available directly by using this import setup. You can use seeds. So numpy.random.seed 101. Why? So that you can generate exactly the same number every time. And so if you run it, you should get the same values as I get. So if you don't provide this number, then every time you run it, you get different numbers. And that may make it difficult to debug a code, right? Because the behavior will be different depending on the random number you generate. So I keep my seed. And then first, you could type this list, right, directly in this form and store it in my index, and you're good. That's fine. But you could do it in a more interesting way by typing the entire list of strings separated by space, right? And then use the split function, which we talked about, which by default separates by space. So it automatically creates the list for you because it figures out A is one string by itself, stores it as the first item in the list, and does same for B, C, D, and E. You could also make this commas, right? Like I said, play with stuff. You can make this all commas. And then you have to provide an argument and tell Python that please split using comma as the tokenizer. We talked about this before, and gets you the same output. I'll take it back so I still have this when I'm explaining in class. And then you can print it, you get the list. You can print the type, you get that it's a list. Nothing special, right? Now generate random numbers from a normal distribution. What are these? The dimension of the normal distribution you want. And the dimension is 5 rows, 5 columns. 5 rows, 4 columns. And those are the 5 rows. 1, 2, 3, 4, 5. How many columns? 1, 2, 3, 4. We said random numbers that are generated from a normal or Gaussian distribution need to have a mean and standard deviation, right? How come there is no mean and standard deviation? Well, because by default, this gets you a standard normal distribution. So it has a mean and standard deviation. What is the mean for a standard normal distribution? 0, right? And then what is the standard deviation for a standard normal distribution? 1. So by default, smallest number will be about -3, and you'll see no number even gets there. The closest is 2.7 on the positive side, and then on the negative side, closest is -2. So that's the reality, because the probability of getting the lower and lower numbers are very low, like you saw from the shape of the distribution. Whereas for this random function, which generates random numbers from what type of distribution? Uniform distribution. Those will go between what and what value? What's the upper and lower limit? Upper is 1, lower is 0, right? And then you're asking for the shape. So here you need a tuple to specify the shape. Here you just provide 2 arguments, which by default is the number of rows and the number of columns. So the functions behave a little differently. So my rand is from the normal, to be precise, my rand is from the standard normal distribution. My rand 2 is from the uniform distribution. And then we print both of them. So this is the one from normal distribution, which goes from about -3 to 3. And this is the one that goes from 0 to 1. So you don't see any number outside of that range. So we're good. Next is, can we put one of them? In this case, we picked the one from the standard normal distribution. Can we put it in a data frame? So it's 5 by 4. Can we have these numbers? Can you have, going down, can you have those in columns? Going down, can you have those in rows and then have this in columns? So basically like pasting this in Excel and having these as the columns, column 1, column 2, column 3, column 4. Yes. And the way we do it is using the pandas.dataframe. Again, Python is case sensitive. You have to start the data frame with capital D and then frame with capital F. So pd.dataframe, then you open and close parentheses. Values first, right? And the value is a 2-dimensional array, right? Of 5 by 4. So at the end of the day, we should have a spreadsheet or a data frame in the context of pandas. You have a data frame that has 5 rows and 4 columns, right? So this is the data that will be sitting in the 5 rows and 4 columns. Well, can I put indices on the rows and on the columns? Yes. Indices will be for the rows, right? Those will correspond to what I showed you earlier in Excel. These 1, 2, 3, 4, 5, and so on are the indices. How about the ABCs and so on? Those are equivalent to the columns, which can be the name of the column you actually provide. So you can specify your index. In this case, what is my index? The ABC through E. So in place of 1, 2, 3, you have ABC through E. And then for the columns, we have what? W, X, Y, Z. And so when you run this, you can see you generate the indices and the columns you ask for. And then these data sets 2.7 that ends at 2.68 is exactly what's stored here in the rows and the column. So if I want this to mirror this exactly, to go from A to E and make the indices go from 1 to 5, very easy stuff, right? You know how to make numbers go from from 1 to 5. Range, right? You can use range, you can use a range. Yeah, I use range. So I want it to start at 1, right? Because Excel starts at 1. So I start at 1, I stop where? To get it to 5, I stop at 6. And then you can put the increment, which by default will be 1. And then for the columns, you can rename those, right? So it's column A in caps, back, A, and do the caps lock, B, and so on. So this will look exactly like Excel with the first 4 columns and 5 rows, right? So you can make it whatever you want it to be, is the point. And then you can more precisely make these the name of the quantities you put in the columns. So this could be oil saturation. It could be the initial oil rate. It could be initial decline rate, parameters that you will actually provide in the dataset. So I'll take this back to what it was, so I don't have to struggle to recreate this by the time I'm teaching this in class, right? So we're back to what we set up originally, WX, YZ, ABC through E. Those functions I talked about, you can use the help.randn. So that will give you some part of the documentation in NumPy documenting the functionality of randn, which is for what type of distribution, and for standard normal distribution. But numpy.random.random, uniform distribution. And then you can find that out from this. You see, they tell you it's for standard normal distribution. And then you can read all of this stuff, which I won't read to you. You can also check this out. For what type of distribution? Uniform distribution. And we'll stop at that and then continue with selection and indexing in the next video.